Hello, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Your screen is
Good
okay?
morning, sir.
Yes, sir.
Yes,
Yes,
sir,
sir.
visible.
Yes, sir.
Screen is visible?
Yes, sir.
Yes, sir.
Okay. The continuation of Fourier series thing. Now, the first point is when C equal to 0. When C equal to 0, then Fourier series of f of x. Previously, we defined Fourier series in the interval c to c plus 2 pi, which is of period 2 pi. Now, when c equal to 0, then Fourier series of f of x in the interval, what is the interval, becomes 0 to 2 pi, is f of x equal to a naught by 2 first term, a naught by 2 first term, second term an cos nx n equal to 1 to infinity plus summation n equal to 1 to infinity bn sin nx. This is the Fourier series general formula, where a naught value is 1 by pi, limits becomes, when c equal to 0, limits become 0 to 2 pi f of x dx. This is a naught. And next one, an value is 1 over pi integral 0 to 2 pi f of x into cos nx dx. Similarly, bn value, we can define bn value as 1 over pi integral 0 to 2 pi f of x into sin nx dx. This is the Fourier series formula in the interval 0 to 2 pi. And the next one, second case, when c equal to minus pi. When c equal to minus pi, then Fourier series of f of x, interval becomes what? C to c plus 2 pi, c value minus pi, c plus 2 pi means minus pi plus pi becomes minus pi to pi. When c equal to minus pi, the Fourier series of f of x in the interval minus pi to pi is the formula. There is no change in the formula always. So the formula is unique. This is n equal to 1 to infinity an cos nx plus summation bn sin nx. But there is a change in the coefficients. What is a naught? 1 over pi, c to c plus 2 pi, c value minus pi to plus pi, this becomes f of x dx, and an value is 1 over pi minus pi to pi f of x into cos nx dx, and bn value is 1 over pi integral minus pi to pi f of x into sin nx dx. Okay, now this is a Fourier series formula in the interval minus pi to pi. And one more point, whenever interval is minus pi to pi, there is a concept of even function and odd function f of x, right? In intermediate level, what is this? There is a note. What is this point? Note, if f of x is odd function, what is meant by odd function? If I replace x by minus x, the function must be minus into f of x. Odd function, in the interval must be minus L to L, like that, generalization. So here our interval is minus pi to pi. Then see, f of x is odd function, and what we have? Odd function. Then minus pi to pi f of x. What is this? Since odd function, integration in between the interval minus pi to pi is 0. This is the concept, right? And and coming to this is odd function, right? This is odd function and this is even function. So what is this becomes now? I'm giving here. This is another one, minus pi to pi. This is f of x is odd function. Cosine nx is even function. So what is this function becomes totally odd function. So this value also 0. This value also 0. And coming to another integral. What is that? F of x into sine nx dx. This is odd function. This is odd function. And what is this total function? Odd. This becomes even function. So what is this becomes? Whenever even is there, I can write this limits as 2 into 0 to pi f of x sine nx dx. Sine nx dx. Okay. So the first point is here. Therefore, the first point is here. The first point. Therefore, and one more point. Let me complete this. Odd function is over now. Coming to even function. Coming to even function, if f of x is even function, if f of x is even function, that is what even function means. What if I replace x by minus x, I will get f of x. I will get f of x in what is our interval? Minus pi to pi. Then what is this? Minus pi to pi f of x dx. What is this become? Since this is even function, I can write this is 2 into 0 to pi f of x dx. 2 into 0 to pi f of x dx. Another one, what is integral? Minus pi to pi f of x into cos nx dx. Cos nx dx. This is even function. Cosine is even function. This entire is what? Even function. This entire is what? Even function. Therefore, this minus pi to pi becomes 2 into 0 to pi f of x into cos nx dx. Cos nx dx. Another integral is what? Minus pi to pi f of x into sine nx dx. Sine nx dx. F of x is even, sine is odd function. So what is this total product? Odd function. So its value 0. Its value 0. Therefore, finally, therefore, point A, if f of x is even, f of x is even function in the interval minus pi to pi, in the interval minus pi to pi, then what is 0? This is even function, right? If f of x is even function, which is 0, which integral is 0? This part is 0. This part is nothing but bn. This is the value of bn, right? So a0 an will be there. Even function, then Fourier series. Then Fourier series of f of x is, what is that? Bn value 0. Only a0 and an terms will be there. So n equal to 1 to infinity an cos nx. Cos nx, equation 1. And where what is an formula? A0 formula. This is actually limits are minus pi to pi. Now this becomes 2 into 0 to pi. Already 1 by pi is there. So 2 by pi f of x dx, a0 value, and an value. This is also 2 by pi integral 0 to pi f of x into cos nx dx. F of x into cos nx dx. Okay. This is about Fourier series of an even function. Fourier series of an even function. Now, when an odd function, the point B, if f of x is an odd function in minus pi to pi, or when odd function, what integrals are zeros? This a0 value, this is a0 value, and this is an value. Both are zeros. Only bn will be there. Therefore, what is the Fourier series? If it's odd function, then Fourier series. Then Fourier series of f of x is f of x equal to a0 0, an 0. So only bn will be there. Bn sine nx. Bn sine nx. Where this is 2. Where What is the Bn formula? Actually, limits are minus pi to pi. Now this becomes 0 to pi, 2 by pi, 0 to pi. F of x into what is this? Sine nx dx. Sine nx dx. Okay, these are the complete formula. First Fourier series formula in 0 to 2 pi. You have to remember 0 to 2 pi formula. Next in minus pi to pi. In minus pi to pi. Then in minus pi to pi, again odd function and even function concept. Odd function and even function concept. Any doubts in this theory? Theory is completed now. Any doubts in theory? Anyone? Any doubts in theory?
No, sir.
Okay. Now I am going to start the problem. First problem. Find the Fourier series of I will mention f dot s stands for Fourier series. Fourier series of f of x equal to 1 by 4 into pi minus x whole square. 1 by 4 into pi minus x whole square. In what interval? 0 to 2 pi. 0 less than x less than 2 pi. 0 less than x less than 2 pi. Okay. First, let me write the given function. F of x equal to 1 by 4 pi minus x whole square. In what interval? 0 to 2 pi interval. First, write Fourier series of f of x. Fourier series of f of x is f of x equal to a naught by 2 plus summation an cos nx plus summation a bn sin nx. Always n is from 1 to infinity over the summation. Take this as equation 1. Equation 1. What is a naught formula? A naught formula in 0 to 2 pi. 1 by pi, 0 to 2 pi, f of x dx. 1 by pi, 0 to 2 pi, f of x dx. Let me evaluate this. 1 by pi, 0 to 2 pi. What is this? Pi minus x whole square by 4 dx. So 1 by 4 pi, integral 0 to 2 pi, pi minus x whole square dx. Okay. What is its integration? Pi derivative 0 minus x derivative minus 1 must be there. So multiply divided by minus 1. I will get pi minus x whole square into minus 1 dx. So minus 1 by 4 pi. This is pi minus x whole cube by 3. Between what limits? 0 to 2 pi. Always, when you substitute the limits, be careful. Okay, you will do mistakes in substitution only. Other integration you can evaluate easily, but substitution of limits most important. Now this is minus 1 by 12 pi whole bracket. Always remember, put upper limit in one flower bracket minus lower limit in another flower bracket in place of x. Now I have to substitute this 2 pi in place of x. This is pi minus 2 pi whole cube. Upper limit is over. Pi minus 2 pi whole cube. This upper limit is over minus. Coming to lower limit in place of 0. So pi minus 0 whole cube. This is closed. Okay. Now this is equal to minus 1 by 12 pi. This is minus pi whole cube minus pi cube. And this is also minus pi cube. So totally 2 pi cube by 12 pi. So this is pi square by 6. A naught value pi square by 6. This is the first value. Okay. Now coming to second one. Now an. What is the formula? 1 by pi. What are the interval is 0 to 2 pi. 0 to 2 pi an. First write the an formula cos nx dx. So this is 1 by 4 pi. 4 I am taking outside in the function f of x. This is pi minus x whole square cos nx dx. Cos nx dx. And so in the last class I told you repeated by parts formula. Repeated by parts formula. What is that? This is derivative part. This is derivative part and this is integrating part. Take the derivatives of the derivative part successively and integrating part integration successively. Okay. When derivatives goes to 0, then stop it. So let me apply that. Listen carefully. First, 1 by 4 pi. I'm applying the limit. First one. First derivative part as it is. Pi minus x whole square as it is. What is cos nx integration sine nx by n? Minus. Now pi minus x derivative is what? 2 into pi minus x and pi minus x derivative minus 1. And this integrating part integration again. This is sine integration minus cos nx by n. N into n, n square. N into n, n square. Any doubts? Once again, derivative part first as it is. Pi minus x as it is whole square. Cos nx integration. Next one, this pi minus x whole square derivative. 2 into pi minus x and pi minus x derivative again minus 1. And this integrating part sine nx by n. Again one more integration. Minus cos nx by n square. Next, this derivative is not 0 now. So again one more. Plus, minus, next plus. Now again for this part derivative. 2 into pi, this minus into minus. Okay, anyway. Again one more derivative. What is this? 2 into pi derivative 0 and this is minus 1, this minus 1 as it is. And one more integration for this cos nx. So this is minus sine nx by n square into n cube. Right? This is now derivative part. Again, what is its next derivative? This is a constant derivative 0. So stop here. Next derivative 0. So stop here. And what are the limits? 0 to 2 pi. 0 to 2 pi. Now, substitution of limits very important. That is equal to 1 by 4 pi. Now, I'm taking substitution of limits. First upper bracket, upper limit. Now, in place of x, 2 pi. This is what, anyway, this sine in place of x, I have to substitute this 2 pi. Sine n pi value 0. So, first term will be 0. This minus into minus plus. 2 into, what is this becomes? Pi minus 2 pi. And what is this cos? And see, this minus, and this minus. Okay. This minus, totally minus you will get here. Totally minus you will get. Once again, minus, 3 minus 2 into pi minus 2 pi. And what is this becomes? Cos 2n pi. In place of x, 2 pi. So cos 2n pi actually plus 1. Okay. In the next step, I will write. Next, coming to this. Anyway, sine 2n pi. What is this value? 0. Minus into minus. Okay. Minus. Anyway, 0. This is upper limit is closed. Minus. Coming to lower limit. 0. Sine 0, 0. This minus. Second term. Minus. Next one. 0 means what? Cos 0 value 1. 2 into pi minus 0. Okay, already this minus 1 included here. Cos 0 means 1 by n square. 1 by n square. And sine 0, 0. This part is, lower limit is also closed. So 1 by 1. Put upper limit in one bracket and lower limit in another bracket. So what is this result? This is equal to 1 by 4 pi. This is minus pi. And this is minus 2. So 2 pi by n square, and cos 2n pi value is what? Cos even pi. Cos even number pi value 1. So this upper limit is over minus. And this value, this minus into this minus becomes plus 2 by n square. 2 by n square. 2 pi by n square. Is it correct? Any corrections? Right. 2 pi by n square. So 2 pi by n square. 2 pi by n square is what? 4 pi by n square. 4 pi by n square. So this value is 1 by n square. This value is 1 by n square. So what is an value? 1 by n square. 1 by n square. Now coming to bn. Now bn formula 1 by pi integral 0 to 2 pi f of x into sine nx dx. Sine nx dx. So that is 1 by 4 pi integral 0 to 2 pi. This is pi minus x whole square sine nx dx. Now again, same logic. This is derivative part. This is integrating part. Let me do. This is this equal to 1 by 4 pi. Once again, if anyone having doubts in previous, now let it be clear. Pi minus x derivative part as it is. Sine nx integration minus cos nx by n square. Put in one bracket. Minus. Now pi minus x derivative 2 into pi minus x into minus 1. Now again cos nx by n square integration, cos nx integration sine nx by n into n, sorry, this is n only, this is n only, and this is n square, this is n square, right? Minus will be as, because cos integration plus sine, so minus as it is placed. Next plus minus again plus. Now for this one derivative 2 into this 0 minus 1 minus 1, again sine nx integration minus cos, so this becomes plus cos nx by n cube. This part is over, and the whole closed. Limits are 0 to 2 pi. Limits are 0 to 2 pi. Now this is equal to 1 by 4 pi. Now substitution of limits. Upper limit in one bracket. First 2 pi. This is pi minus 2 pi whole square, and this is minus cos 2n pi by n, right? Next, this minus anyway sin n pi 0, second term will be 0. Coming to third, minus into minus plus, so plus 2 by n cube cos 2n pi. This is upper limit. This is upper limit. Minus, I will write here, minus lower limit 0 in place of this. So what is this? Pi minus 0 whole square. Why it is coming like this? Pi minus 0 whole square, and cos 0 1, so minus 1 over n. Next one, this is sine 0 0, so 0. Next one, plus cos 0 value 1 minus into minus plus, so 2 by n cube. This part is closed, and the whole, this is closed. Upper limit minus lower limit. Upper limit minus lower limit. Now this is equal to 1 by 4 pi pi minus 2 pi minus pi whole square means pi square. Cos 2n pi value 1, and this minus as it is, minus by n, and cos 2n pi, that is plus, so 2 by n cube as it is. This is upper limit value minus. Coming to lower minus pi square by n, minus already it is there, plus 2 by n cube. Now if I simplify this 1 by 4 pi, this is minus pi square by n, this is plus pi square by n, gets cancelled, and 2 by n cube minus 2 by n cube also gets cancelled, so this value 0. So bn value 0. Substitute a0, an, bn in equation 1. What is equation 1? F of x equal to, what is a0 value? I think pi square by 6. A0 value pi square by 6, a0 by 2 plus summation n equal to 1 to infinity. What is an value? 1 by n square cos nx, and bn value 0. So this is equal to pi minus x whole square by 4 equal to pi square by 12 plus summation n equal to 1 to infinity cos nx by n square. This is the equation 2 is the Fourier series, of f of x, given function f of x. Okay, this is over actually, but see what happens here. Pi minus x whole square by 4 equal to pi square by 12. Let me expand this. This is cos x by 1 square, cos 2x by 2 square, cos 3x by 3 square, and so on, and so on. If I put x equal to 0, then what is this? Pi square by 4 equal to pi square by 12, 1 by 1 square, 1 by 2 square, 1 by 3 square, and so on, and so on. So what is the series expansion? 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on equal to what? Pi square by 4 minus pi square by 12, right? So 12 will be there. This is 3 pi square minus pi square. So what is the value? 1 by 1 square, 1 by 2 square, 1 by 3 square, and so on equal to 2 pi square by 12, pi square by 6. Pi square by 6. In the question, okay, this is what is, for example, in the question, if it is added, which one? Also deduce the value of 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. If the question is like this, okay, after getting the total series expansion, put suitable substitution for x. Because I need 1 by 1 square, 1 by 2 square, 1 by 3 square. The suitable substitution for x is 0. From that, I got the value 1 by 1 square plus 1 by 2 square plus 1 by 3 square, value as pi square by 6. Okay, this is one problem. Any doubts in the first problem? Okay. Second problem. Expand f of x equal into sin x in the interval 0 to 2 pi. In the interval 0 to 2 pi as a Fourier series. Now, solution. F of x equal to x into sin x. And the interval is what? 0 to 2 pi. See, what is the change in this problem? 0 to 2 pi. Formula a naught by 2 summation cos nx bn summation sin nx. Equation 1, where first one a naught value 1 by pi 0 to 2 pi f of x dx. 1 by pi 0 to 2 pi f of x is what? X into sin x dx. Now, as repeated by parts, this is derivative. Minus x derivative 1. Again cos x integration sin x. Next one derivative 0. So stop here 0 to 2 pi. Now substitution of limits. First upper limit 2 pi minus 2 pi cos 2 pi minus into minus sin 2 pi, this value 0 anyway, minus x plus in place of x 0 and sin 0 0. So this value is 1 by pi cos 2 pi 1 sin 2 pi 0. So this is minus 2 pi simply. So value is what? Minus 2. A naught value minus 2. A naught value minus 2. All of you, everybody is getting? Any doubts? Hello? Any doubts?
No, sir.
No, sir.
All of you, any doubts?
No, sir.
No,
No,
sir.
sir.
No, sir.
ఏంటి వింటున్నారా? పక్కన పడేసి పడుకున్నారా?
వింటున్నాం సార్.
వింటున్నాం సార్.
Right. Now, an value 1 by pi, 0 to 2 pi, f of x into cos nx dx. Cos nx dx. This is 1 by pi, 0 to 2 pi. F of x is what? X into sin x into now cosine nx dx. Cosine nx dx. Now, within the integration, there are three functions. Integration of product of three functions. So to solve this, let us multiply divided by 2. Multiply divided by 2. So what is this? X into 2 sin x cos nx. This term together dx. That is equal to 1 over 2 pi integral 0 to 2 pi x into what is 2 sin a cos b formula. 2 sin a cos b formula. What is that? Sin a plus b. See, a value x, b value nx. A plus b, x plus nx. Take x common. Right? Sin a plus b plus sin a minus b dx. Sin a plus b plus sin a minus b. Okay, now this is equal to pi. Now taking integration.
Sir, it is struck.
One minus x by 1 n. First term is over. Right? Now I will write here minus. Derivative is what? 1. X derivative is what? 1. Again, cosine integration. This part integration. This bracket function integration. Cosine integration is what? Sine. 1 plus nx by 1 plus n into 1 plus n. 1 plus n whole square. Minus. Cosine integration is what? Sine 1 minus nx by 1 minus n. 1 minus n into 1 minus n. 1 minus n whole square. This bracket closed between what limits? 0 to 2 pi. Next one, why I am not writing? Because one derivative is what next? 0. So stop here. Bracket. This is 2 pi. I will write like this. 2 into 1 plus n pi. 2 into 1 plus n pi by 1 plus n. Minus is there. Minus cos 2 into 1 minus n pi. 2 into 1 minus n pi by 1 minus n. Okay, and let me, this is, okay, this minus into minus. Okay, take minus common here. So this becomes what? Okay, this bracket closed, and this becomes what? Plus. Okay, minus common here. This minus common here. Anyway, sine n pi value is what? Always 0. So this second bracket will 0, completely 0. Second bracket is completely 0. Sine n pi, sine 2n pi you will get here. Sine 2n pi you will get here. So 0. This is upper limit. Now Coming to lower limit, minus. Lower limit 0. Lower limit 0. When I substitute 0 in place of x, 0 into something 0. This is upper limit. This is first term. Minus into minus, lower. This one also. Sine 0 is also 0. So this lower limit value entirely 0. Lower limit value entirely 0. Once again, this 0 substituted here. 0 into something 0. Sine 0, 0. So lower limit value completely 0. Now this is equal to 1 by 2 pi. So what is cos 2? 2 into something is what? Even. So cos even pi plus 1. So 1 by 2 pi. What is it? Becomes 2 pi. This is minus 1 by 1 plus n. This is also plus 1. Minus 1 by minus n. Only these terms are left over. So this is the value. Now let me simplify this. Take minus common. 2 pi also gets cancelled. So minus common outside. 1 by 1 plus n plus 1 by 1 minus n. Okay. Now this is a naught is equal to, what is this? Minus, this is 1 plus n into 1 minus n and 1 minus n plus 1 plus n. So n gets cancelled. This is minus 2 by 1 minus n square. Nothing but 2 by n square minus 1. 2 by n square minus 1. So one can write a naught equal to 2 by n minus 1 into n plus 1. Right? A naught value 2 by n minus 1 into n plus 1. This an is valid for n not equal to 1. This symbol, this one, when n equal to 1, what is this one? At n equal to 1, what is a naught tends to infinity? A naught, this is a n, sorry. This is an. An tends to infinity. Therefore, this an is defined only for what? N not equal to 1. For all remaining terms, its value is, for n equal to 2, 3, 4 and up to infinity, its value is 2 by n square minus 1. Okay, so, but what about a1? Therefore, now I have to calculate this one separately. Now, for n equal to 1, what is a1 formula? For n equal to 1, what is actually an formula? This is 0 to 2 pi f of x into cos nx dx. Okay, cos nx dx is the formula. Now, this implies what is a1 becomes 1 by pi 0 to 2 pi f of x into cos x dx. Cos x dx. So, what is this? 1 by pi 0 to 2 pi. What is the function? X into sine and sine x. X into sine x cos x dx. We have to calculate a1 separately when it is not defined by using again the formula. So 1 by 2 pi 0 to 2 pi x into 1 can write 2 sine x cos x sine 2x. Okay, this sine x cos x multiplied by 2 sine x cos x sine 2x. Okay, now this is equal to 1 by 2 pi, again same repeated by parts formula, x derivative part sine 2x integration minus cos 2x by 2 minus x derivative 1, again one more integration for cos 2x sine 2x by 4 and 1 derivative 0. So stop here, 0 to 2 pi. Now 1 by 2 pi, limit substitution. First upper limit, this is minus, I will write minus here in place of x 2 pi. This is cos 4 pi. You will get cos, okay, let me write cos 4 pi by 2. Minus into minus plus sine 4 pi. A1 value, 2 gets cancelled. So cos 4 pi value 1. So minus pi you will get. So minus 1 by 2 you will get. A1 value minus 1 by 2. This is separate. Now, Bn value. Bn equal to 1 by pi minus pi, sorry, 0 to 2 pi f of x into sine nx dx. Sine nx dx. So this is 1 by pi 0 to 2 pi x into sine x into sine nx dx, right? Multiply divided by 2, 1 by 2 pi 0 to 2 pi x into 2 sine x into sine nx dx. 2 sine A sine B formula. 2 sine A sine B formula. Integral 0 to 2 pi x into sine A sine B means what? I think cos A minus B. Cos A minus B and cos A plus B dx. Cos A minus B. A value x, B value nx. So x is common. Cos A minus B minus cos A plus B, 2 sine A sine B formula. That is equal to 1 by 2 pi. Now take the integration. This is derivative part and this entire is integrating part. So derivative part as it is and integration part integration. Cosine integration plus sine by 1 minus n quotient minus cosine integration again sine 1 plus nx by 1 plus n. First term is over. Next one, x derivative. This is minus x derivative 1. Again, integration of this total. Sine integration minus cos 1 minus nx by 1 minus n into 1 minus n square. Right? And sine integration minus cos. So this becomes plus cos 1 plus n. Cos 1 plus n x by 1 plus n whole square. This is over. And one derivative next 0. So this big bracket closed now. This limits 0 to 2 pi. 0 to 2 pi. Now substitution of limits. 1 by 2 pi, big bracket. Now 2 pi, upper limit. See, this is 2 pi into, this is 2 pi, this is 2 pi. So sine of something n pi is always 0. So first term will be 0. Minus. Coming to second one, yeah, it will be there. This term will be there. What is that? 2 pi. This is 2 pi. Cos even pi 1. So this is minus 1 by 1 minus n whole square. Once again, 2 pi here. 2 into something is even pi. Cos even pi plus 1. So minus here. So minus 1 by 1 minus 1 whole square. Same logic for this. 1 plus n into 2 pi. 2 into something is even. So this is plus 1 by 1 plus n whole square. This is upper limit. Minus. Coming to lower limit, this 0 is there. 0 into something 0. So first term will be 0. Minus. Coming to second one, this cos 0 value 1. So minus 1 by 1 minus n whole square plus 1 by 1 plus n whole square. This is second one. This bracket closed now. And the whole bracket closed. Now see what happens here. 1 by 2 pi. What is this is plus this minus. And coming to this minus into minus plus. So this becomes minus 1 by 1 minus n whole square plus 1 by 1 plus n whole square. I think every term gets cancelled. 0. Every term is getting cancelled. Bn value 0. This implies Bn equal to 0. Bn equal to 0. Again, same logic. See, this whenever this value is not valid for 1, when I took the integration for this is, you can write here, this is for n not equal to 1. Why? Because this denominator term is there, 1 minus n. So this Bn equal to 0 for what value? For n not equal to 1. Bn is 0 for n not equal to 1. So again, you have to calculate B1 separately. Now, therefore, for n equal to 1, what is Bn formula? 1 by pi, 0 to 2 pi, f of x into what? Sine nx dx. This implies what is B1 becomes 1 by pi, 0 to 2 pi, This is x into sine x, and this becomes what? Sine x only. N value 1. N value 1. So this implies b1 equal to 1 by pi 0 to 2 pi x into sine square x dx. X into sine square x dx, correct? Yeah, that this equal to 1 by pi 0 to 2 pi x into sine square x means what? 1 minus cos 2x by 2. 1 minus cos 2x by 2. Okay, so this is this equal to 1 by 2 pi integral 0 to 2 pi x minus x cos 2x dx. Correct? Right? This is equal to 1 by 2 pi. This is x square by 2 for the first one. Okay, big bracket. This first integration between the limits. Coming to second integration, derivative part, x is derivative part and cosine is integrating part. Cosine integration sine 2x by 2 minus x derivative 1 and sine integration minus cosine 2x by 2 into 2, 4. This is between 0 to 2 pi. This is between 0 to 2 pi. So this is 1 by 2 pi. This is what? 4 pi square by 2. Lower limit 0. This is over. Coming to this, again big bracket. In this one, upper limit 2 pi. Sine 4 pi 0. This minus into minus plus. In place of x 2 pi. Cos 4 pi. Cos 4 pi means positive. So 1 by 4. Upper limit is over. Coming to lower limit 0. In place of x 0 into something 0. Minus into minus plus. Cos 0 value 1. 1 by 4. Okay, this closed and this whole closed. Brackets are important. Now what is this? 1 by 2 pi. This is 2 pi square. And this is plus 1 by 4 and this is minus 1 by 4, that is 0. Okay, these two gets cancelled, that is 0. So answer is what? Pi. Right? Therefore, B1 value is pi. B1 value is pi. So finally, therefore, the Fourier series is f of x equal to, Fourier series is f of x equal to, what is first one? A naught value. What is A naught value? Anyone? At the beginning.
Minus 2, sir. Minus 2.
Minus 2, sir.
Minus 2. Okay, right. This is A naught value minus 2, A naught by 2 plus. Now, that Fourier series you have to split because A1 we calculated separately. Separate that. 2 to infinity an cos nx. Okay, let me write. This is A naught by 2 plus similarly b1 sin x plus n equal to 2 to infinity bn sin nx. You write like this. This is minus 2 by 2. And what is A1 value?
Minus 1 by 2.
Minus 1 by 2 cos x. And what is an value? General an value? 2 by
n square minus 1.
2 by n square minus 1 cos nx. And what is b1 value? Pi. And bn value 0. Right? Therefore, what is this? This is f of x. And what is f of x? Actually is x into sin x. This is minus 1 minus cos x by 2 plus summation n is 2 to infinity 2 by n square minus 1 cos nx plus pi sin x. This is the required Fourier series. Required Fourier series. Okay, this is the problem. And I think you got the catch the logic. What is this? First write the Fourier series and evaluate the quotients a0, an, bn, and see an, bn are defined for all n. If something is not defined, and remember n must be positive integer only. So when in denominator n minus 1 terms are there, the quotient is not valid for that n equal to 1. Calculate that value by using again formula by substituting n equal to 1. Okay, and main parts are evaluating by parts, Evaluation using repeated by parts formula. Repeated by parts formula, right? And next one, substitution of limits. Substitution of limits. Upper limit and lower limit. Upper limit in one bracket, lower limit in another bracket. Okay. Now just take this assignment. Try this problem. Find Fourier series of f of x equal to e to the power of minus x. F of x equal to e to the power of minus x in 0 to 2 pi. And next one, in 0 to 2 pi, I need a f of x equal to, already I did this, no problem. F of x equal to e power x is given. E for minus x is also over. In minus pi to pi are there. Can you do in minus pi to pi?
Yes, sir.
Yes, sir.
X in 0 to 2 pi. Try this, minus pi to pi, I will give f of x equal to x minus x square. X minus x square in minus pi to pi, and deduce the value of, take this plus, x plus x square, reduce the value of 1 by 1 square minus 1 by 2 square, 1 by 3 square, 1 by 4 square, and so on. And so on. Let me give another one. 1 by 1 square, 1 by 2 square. Yeah, same problem. Anyway, I will tell this. Simple. Okay. These 3 problems assignment. Any doubts in today's class?
Sir, in first example, pi minus x whole square by 4, that problem. Sir, if we substitute...
First example?
Sir, if we substitute...
Voice is not clear.
If we substitute
If I substitute?
Pi by 2. X equal to pi by 2.
Where?
Sir, in the Fourier series.
Is pi by 2 integer?
No, sir.
See, no, you see this n value, you see this n value must be integer. This here, this value, this an is not defined for n equal to 0, but n equal to 0 is not there na in an. An starts with what in formula? 1.
Yes, sir.
Don't take x values. Don't take x values, only n values. For any n, if quotient is not defined, calculate separately. Okay?
Okay, sir. Thank you, sir.
Okay. Okay, next class is there now, so I will stop here.